Right, okay. The slides are all online. There is text which is incredibly tiny when you're sat, even from this range, it's very tiny. So if you want to have a look at the examples closer up, then bit.ly/shapeUpAI should get you a copy of the slides in the deck. If it doesn't work, I will fix that later. Who is this Miles Berry? What does he know about AI? You type that into the machine and it gives you a reasonable summary. It's being very kind. It hasn't actually made anything up on this particular occasion, which is always a relief. But it misses out lots of the cool stuff and the important stuff. So I spent 18 years working across 4 different schools. Much of that time I was a maths teacher. I did 3 years as a primary head teacher, which was quite enough. Thank you very much. My current job is training the next generation of teachers at the University of Roehampton in computing education. Not as though I'm an imposter here at the these associations conference, but I kind of slip in because I'm helping with this Royal Society Mathematical Futures, which has been tremendously exciting and interesting stuff. Anyhow, that's enough about me. What are we meant to be doing? What is the point of school curriculum? Well, according to the 2002 Education Act, it is about promoting the spiritual, moral, cultural, mental, physical development of pupils at the school and of society. The society clause is rather lovely in that there is a wider purpose to what we do than just educating the kids in our care, but also to prepare pupils at the school for the opportunities, responsibilities and experiences of later life. What does that mean for the kids who are in primary school at the moment, for the kids who are in year 9 at the moment? What will the opportunities, responsibilities and experiences of their later life be? It seems likely to me, and to, I suspect, many of us, that technology is going to play kind of an important role in those opportunities, responsibilities and experiences, and AI seems to be the hot topic in terms of what will the future that we're preparing them for be like. The Department for Education says in a policy statement that we should teach students how to use emerging technology, such as generative AI, safely and appropriately. And I think it's fabulous that we have that encouragement from the ministry, that teaching kids how to use these tools should be something that's happening in school. And yeah, the safe and appropriateness is part of it. Again, one of the things it missed out in its Who is Miles Berry was part of the panel who put together England's computing curriculum. Blame me or thank me, depending on your perspective on that. And the model that we had in mind was that it should have these 3 elements to it: the computer science, the information technology, the digital literacy, if you will, the foundations, the applications, and the implications of computing for individuals, for society, the whole lot of that. I think that model of foundations, applications, implications translates really well when we start thinking about AI. What should we do our young for those experiences? So part of this should be about how this works. And a good understanding of that, I think, requires a certain math in all. How can it be used? They've got lots of experience already, certainly the ones who are over 13 and age have that, but how can we use it? It's really one of the... And then, of course, the big thing that I should make sure I leave some time for at the end, about what does this mean for our profession, for their futures. This is not something to just forget about. Let's start then at the beginning with the foundations of this. So when I was doing an O-level in computer studies, we were taught a computer is a machine that accepts input, processes it according to a stored program, and produces output. Andrew is teaching computer science, is probably teaching much the same thing, yeah? Accepts input, processes it, produces output. It's no longer quite true. Okay? Actually, what's going on in most of the tools that we're using now is a little bit closer to this, that input and output are linked not by a program that somebody, wearing a hoodie sat behind a screen, black text, black background, green letters, has written, but by a model that the machine itself has determined from training data with which it's been provided. So that training data determines the model rather than the programmer themselves. And okay, there is human involvement here. We select the training data. We choose the particular algorithm to use to determine that model from the training data. And getting those right matters a lot now. A lot of this bottom bit is done kind of automatically. There are some lovely resources out there. So this is, and it's an interesting date. Joan's writing for the American version of this, National Council of Mathematics, in 2021, a year before everybody else cottoned on to large language models and ChatGPT, has this lovely thing about how does the predictive text thing on your phone even work? You start, I'll call you, and it says, okay, the next 3 most likely words are going to be in, when, later, I'll call you later. Always a good text to respond with. And he has this lovely exercise of here is some examples of phrases on a phone which we begin with, I'll call you. Let's have a look at how much time each phrase comes up. And it turns out on the training data that Jones has here, I'll call you when comes up with 4 out of the 10 examples in his training set. So that's the one that it picks comes next, yeah? Makes sense. Small language model. We can do this with pen and paper and bits of card. We can also do this with code. So here I have given Python the text of 3 Shakespeare plays. Okay, here we are at Stratford, and said, create for me a list of the trigrams in there, the 3-word groupings. Okay, so, you know, to be or would be a trigram in this set because it has the text for Hamlet. So it's each combination of 3 words. Look at that trigram set. If I tell you the first 2 words, you can work out the relative probabilities of the 3rd word in that training set. Yes? Kind of makes sense? And here is, here is some code to do that, to work out the probabilities for each 2-word combination, the probability of the 3rd word in there. So if I start with the first 2 words are he is, according to those Shakespeare texts with the original spelling, he is dead happens 12.5% of the time. He is, well, quite, yeah, everybody dies. He is comma, okay, fair enough, comma counts as a token for this. He is mad 6 and a bit % of the time. So we've got all of those coming up, yeah? And you know where, I hope you guessed where we go with it. Isn't this like some sort of Markov chain going on? So we know, given the first 2 words, the 3rd word I can choose randomly according to the probabilities. I can roll some dice. If I get, you know, a high score, pick the most likely one. If I get a very low score, pick one of the less likely ones. And now I've got the 3rd word in my set. Again, look at the 2nd word and the 3rd word. You can pick what the 4th word is. 3rd word and the 4th word, you can pick what the 5th word is. Richard wants to talk about recursion at this point, but I'm not going to let him. Okay. But we can write code to do this. We can generate a whole sequence of Shakespeare-like sentences from this, yeah? They're not grammatically correct, but we're just modeling Shakespeare's use of language, or possibly Bacon's use of language. Who knows? Okay. And that's essentially what's going on in the large language model, except it's not just looking at 3 Shakespearean texts. It is using things which are an awful lot larger corpus of text to go from. So before they released ChatGPT, there was the GPT Playground, which was just a completer. Here are 5 ways in which AI can be used to provide access to the curriculum, and then fill in the blanks, using that Markov-like stochastic process. Okay, 5 things. The next thing it's going to say is 1, and then it has to roll the dice. It picked the word natural to come in next. Once I've chosen natural, language processing is a fairly obvious one to put next. My example here, machine learning algorithms can be used to identify was the most likely. But remember, it's rolling dice. This is a probabilistic. And so chose analyze there 19% of the time. If it gets a really low score and picks a really weird word next, it has to live with that choice. And choices have consequences, yeah? So it's picked an unlikely word, but the next word is determined by that choice. And so you get this hallucination phenomena of it's chosen something weird, but it's got to live with this, it's got to carry on using that, and so it comes up with stuff which isn't, I don't know, strictly speaking, true. It is, as you know, a little bit more complicated than that. So we have man is to king as woman is to queen. Very good. It's illustrated on the slide behind me. And we can think of those as the words as having coordinates in some very large dimensional space. In this particular example, I'm only representing the things of age, gender, and royalty there, and each word is located as a point in 3 space. But it's going to be a lot more than that. You draw the diagrams provided. The vector that takes man to king is parallel to the vector that the queen analogy. So what GPT and other large language content of the word rather than just the problem. And okay, this is kind of hand coded, but it gets these numbers from other words in the corpus on which it has been trained. And then you get this sort of crazy idea of this is actually invariant across languages. If we were to do this en français or auf Deutsch, we'd have the same vector, yeah? The link between man and king and woman and queen is parallel irrespective of the language that you're working in. And so you have that lying right at the heart of this as representing, yes, the word, but also the idea of the word in some sort of numerical, multi-dimensional form. But I don't know, the researchers saying Google has come up with its own language, like, I don't know, unearthing some pre-Enochian deep grammar or something there. They told us for GPT-3 what they'd use to train it. Put your hand up, please, if you have an account on Reddit. Thank you very much. Put your hand up, please, if you've posted content to Reddit. Very good, sir. The link you posted is there in the training set for GPT-3. Fabulous! You've helped build this language model.
It's not my
this
fault.
is, but this is web text 2, which are the pages that people have linked from Reddit, which was 22%. You might feel that the people who posted links to Reddit are not necessarily the people on whom we want to base all of the 22% of this, how we are responding. It really is. Yes,
there's a couple of really nice bits, but the rest of it properly.
You are allowed to say that. Okay, that's fine. And I don't know, do you remember the time when we said you can't Wikipedia? Yes. Wikipedia has been made up by people. Now we come back. Oh, it was made up by actual people. It was a golden age that Wikipedia was paid attention to 3.5 times proportionate amount of the training mix. Wikipedia is very good in my view. And the fact that people care and correct it, it's a good starting point. People were involved too. So you've got, remember that thing about the training data. So here is where it's taken its understanding of language from. And then they get people involved of applying rules to this. So given this prompt, please write a good response to this. People who work for OpenAI do that. And, they establish what a good response looks like. Then there's the comparison stuff of this is a better response than that, so pay more attention to this. And then there is now we've let the model go live. Some of the time it's going to make decisions, and we need to come back and realign the weights of the model. Training this model is very complicated, environmentally expensive. Tweaking it once it's been trained, that's much more reasonable. So you've got people involved too. And again, you have to wonder, OpenAI's rules for this, were they the sorts of rules I would want my pupils to be using? Do they represent our values or the values of other people? So now we have GPT-4, which is fabulous. Technical report for GPT-4. This report contains no further details about the architecture, including model size, hardware, training, compute, dataset, construction, training method, or similar. The firm is still called OpenAI. They're not being particularly open there. Okay, let me move on. So what about how we can use it as teachers? So there are, again, the Department for Education, isn't it fabulous to know The teacher workload is an important issue to the DFE. We're committed to helping teachers spend less time on non-pupil facing activities. I'm so glad that they've told us that now. That's so reassuring. So any way we can use this to allow us to spend more time with the kids seems to me to be a sensible thing to do. Yeah? If there are occasions when you find yourself writing and aren't enjoying writing and would rather be spending time with the kids, that's probably something where GPT could lend a hand. There are a number of click-based interfaces for this, because writing a prompt is obviously too difficult for teachers. So this one, TeachMate AI, is lovely. This gives you ideas of the sorts of things you can make it do. This just acts as an interface to GPT, usually 3.5 here. So you click on the thing, you give it some parameters, it sends the prompt to GPT 3.5. It comes back with a response and shows you on their website. What is this? Magic School AI is my favorite of these because it has the teacher joke generator. And you will all be familiar with that experience on a Sunday evening. Oh my gosh, I've got a whole full timetable for the week ahead and I haven't written any of my jokes. Okay, this is clearly where the AI can lend a hand with that. Is there anything worse than a teacher joke? Yes, a joke generated for a teacher by the machine, I would suggest. DFE, bless them, over the October half term, if memory serves, produced the report, consultation running over the summer. How are teachers already using this? And we have a list of 7 things there. The live use in lessons, I think, is really interesting. I'd love to hear more about others' experience of that. But yeah, administrative tasks, come on, that's a sensible thing. Using generative AI to proofread, edit, and improve writing. I've got my students handing in an assignment in 52 minutes' time. I sent them the message to say, look, ask GPT what it thinks of your writing. Pay attention to the response it gives you. That's not cheating, to my mind, nor by my university's rules. And it's something I will routinely do for stuff I'm writing is, how could I improve this? What have I missed out? It's not the same as asking it to read this. So then let's do the worked example. Sometimes I risk doing this live, saying to the audience, give me a topic, give me something, modeling how we can get it. Summary and I've prepared this in advance. You never know with you, do you? So we've got this thing about, can you factorize it? It's there on the GPT. You will, I hope, all have taught this or something similar. But your example. Firstly, this zero-shot, using it instead of your search engine choice. Did you hear the news about Google start charging you for AI supported search? There's a thing called do this for you. Tried using it instead of Google, and in some ways it's so much better. You don't advertise. Pause for a moment in which the large organizations are very scared at this point. So tell me everything I need to know about factorizing quadratic expressions, and it gives us this. I'm not going to read it to you now. Technical language. Rewrite this as if I were a 14-year-old having to learn this. Can you put this into slightly more child or indeed human-friendly language? Imagine you have a little treasure chest, your quadratic expression that's locked tight. To open it, you need to find the special key, the factors that fits perfect. It's a really nice mental model. I don't know if it necessarily helps, but it might make it a little bit more sticky than that did. And the whole idea of factorization as a way of unlocking things has, links to cryptography, which we're not going to do now. Okay, that's really helpful. Thank you. I try to be polite to these machines because I am quite literally training them. What are the implications of... what are the common misconceptions? Have to explain what I mean by a misconception that pupils have with factorizing quadratics. All quadratics can be easily factorized. Yeah, misunderstanding the role of the leading coefficient, confusing term. And it's helpful for somebody who's not gone through PGC, who's non-specialist, teaching this, thrown in at the deep end here. What could it be that my pupils don't know about this? My trainees over in computing education find it really hard to imagine what students will not merely not understand, but have a pre-existing wrong model of this. It knows about your theory of variation thing. So give me some questions based on this idea of a theory of variation. Factorize x squared plus 5x is 6. Then try x squared plus 5x minus 6. How does changing the sign of the constant term affect factors? Generalize, and it goes through. Contrast with irreducible quadratic factorize x squared plus x plus 1. And at which point everything that you've learnt so far breaks down. It's a lovely structured sequence of questions. And you all can write these well, but this is not a trivial thing for a maths teacher to put together. It takes time to get right. I'm paying for this $20 a month for GPT-4. GPT 3.5, it's worth trying it. It really is. 3.5 is the current version of... Sorry, converting the rational to a decimal for you there. Sorry? Yeah, if your school is...
Even without just
Whoa!
a free account.
Okay, thank you for that.
Anyway.
Good for that.
As far as I can tell.
Yeah, okay. And you kind of want to know what
Yeah.
they're going to get. Don't go too far down that. So our friends at Oak National Academy have got their quiz generator. So you go in there and you choose a key stage, choose a topic, give it a question, and then it will produce 4 reasonably good multiple distractions for you. Interesting, and I do not know why the list of subjects available has at least one notable exception there. I'm curious as to why they've not released the quiz generator for mathematics. But this is genuine curiosity. This is not, and I'm going to tell you. Okay. These are those horrible context questions where you've got to firstly understand what it is they're talking about before you get the naked quadratic that you can then factorize. And I don't know, a gardener wants to create a rectangular garden that has an area represented by the quadratic expression x squared plus 14x plus 48. It comes up so much in real life, doesn't it? And you will find maths textbooks with this sort of thing exactly in them. Okay, and we've got other examples. Some of this is a little bit better. The flow of traffic through a bottleneck on a highway can be modelled by this equation. And this is getting harder by this point. Okay. And then I did so then there's the classic thing about write me a lesson plan. And this is the thing I worry about my trainees doing, of create me a lesson plan for the thing, because we make them write lesson plans. Well, because we had to when we were training to teach. Obviously, as somebody who's never taught before, they're bound to be good at writing lessons. Well, I don't know. It's a thing that they have to go through. And it will do a reasonable job of this. The people in the room would write. Sure, but there's an awful lot of really bad, as you will know. And the more instruction you give it, say we do the I do approach planning. This is what I want to do. I said just introduce the topic. It's been kind of ambitious to cover in one lesson. I feel a little bit longer to get to wherever it is. But it's a starting. And using it as a starting point doesn't seem unreasonable to me. What next? Then the thing I was thinking about this morning, about this notion of the rich task, the stuff which has lots of opportunity to explore patterns and to figure out interesting things. And with that, I say what we mean by a rich task, or I ask it, what do you think I mean by a rich task? So I've primed it, and then I say, write me some rich tasks in the context of factorizing quadratic. I think there's some really nice things here. Target product, target sum, ask students to find 2 numbers that multiply to the product and add to the sum. It's the kind of thing which many of you, I'm sure, would do. We've got this lovely sorting activity, set of cards with various quadratic expressions, some of which are factorable and some of which are not, and sort them into... I don't know as I would have immediately thought of it myself. It's kind of what I will fess up to in front of you. And then if you want it to go off and write code for you, it will gladly write code for you. So wouldn't it be lovely to have a thing where I can move the sliders and change the coefficients and see what the factorization of the quadratic would be? In all honesty, folks, Probably not, but if you want that, it will make one for you. And that's quite powerful. This may not be our best example of this, but it is very, very happy with GPT-4 to go off and write code to do something. The token that comes next is code. It's writing it for Jupyter Notebook, which it asked it to do. The first version. Let me run it now. I've got the notebook. I've got everything. It will, if you tell it for this, it will do its level best to do that. That's really nice. Thank you. That's really helpful. Yeah. Okay, so it can make you interactive activities, whether they're helpful or not. I like my pupils to remember how to do this. Can you write a summary of the approach as a sonnet in the style of William Shakespeare? Normally I do as a rap, but I thought, we ought to honor the bards. So, in algebra's realm, where numbers dance and play, where x and y hold court in silent might, a quest unfolds in the broad light of day, to factorize, to solve, to bring to light. Quadratic forms, ax squared plus bx plus c, a challenge posed, a puzzle to unbind. Seek factors twain that when multiplied you see, return the form original aligned. I don't think it's quite there on the standard of shall I compare thee to a summer's day, but it's made a start on this. Okay. Sorry. You know where you are with the stereotypes, sir. Right. Okay. And then, it struggles with this. In some contexts, it produces a really good, thought-provoking image. My usual go-to is show me a picture of a pirate, hacking into a computer system. But here, it's got the thing about the chest with the lock, which is kind of nice. It might help them remember it, but I don't think it's a particularly good visualization of the process, in all honesty, folks. Oh, well, yes, okay, if you've got to be picky about it. Yeah, I can't actually see a padlock on it either, but, it's tried. And again, the interactive activities, we did Mobius bands yesterday with Katie's wonderful keynote. Give me a visualization of a Mobius band. It will write code and then allow you post that code into Jupyter Notebook, and it gives you an interactive thing. Does it help? No, it would be better to do it with paper. Folks, there are other things that teachers find themselves having to write. Sophie has tried hard in her maths lessons, but has been inconsistent in homework. She scored 83% on the exam, losing marks on multiplying fractions and conversion. For us as parents, that's actually probably enough, yeah? But there's this big box on the report, yeah? Take this information and then make the information density much, much lower by throwing in some random, padding words, and it will gladly do that. It's not long until the parents take this text, put it into ChatGPT, and give me a one-sentence summary of this. Cut out the middleman, please. I don't know if any of you have to do this for work, but, here are their tests before we did the intervention. Here are their test scores after the intervention. Give me this as some sort of chart. You know how to use Excel. You can do it on graph paper yourselves, folks, yeah? And it will gladly do that. And then I'm interested in, have they made progress? Particularly, have they made significant progress? Yeah? I can't say they've all got better. There's a child I want to have a word with here. Yeah, it didn't work for them. But on the whole, most of them are above the line. My feeling is, yes, this is intervention. It is interesting how it responds. So on the left is its first attempt. Did pupils make good progress between the two tests? Yeah, they're above the line. The scores are pretty good. It feels as though its initial response was a very human reaction to that data. Because I have the domain knowledge, I say, could you please do a paired sample t-test to establish whether there is a statistically significant improvement? And it says, yeah, that looks as though that was pretty good teaching or the intervention works. But I had to ask it specifically for that. It didn't volunteer, oh yeah, I'll do a t-test for you. Yeah, interestingly. And you can do this at scale. This is national Key Stage 2 to GCSE results. Schools with good Key Stage 2 results get good GCSE results. Shock horror. I don't think you need to buy the books or go on the courses about how to prompt well, because what I've been doing there is pretty much what I would do with students. I wouldn't generally ask them to summarize this as a sonnet, to be honest with you, but the dialogue, the conversation about, okay, that's a good starting point, now can you do it this way? Give me some examples of rich tasks. I think we're pretty good at coming up with stimulus to which people, things, entities respond, because it's like part of our job. There is cool stuff going on, like giving it samples to work with, fine-tuning it on the basis of exam papers, examiners' reports will get you better results for that particular domain. And tweaking the model is way, way easier than training the model in the first place. You know most of this. It is just predictive text. It is just choosing which token to show you next. It doesn't actually understand the thing it is writing. And there's a really interesting, deep philosophical thing about it fakes understanding. How can I tell my pupils understand this thing? Well, they respond to me in words. They give me one token after another, and from that, I can tell they understand this. It does that very, very well, but it doesn't understand. What do we mean by to understand? Those of you who've worked for rewarding organizations know that you should never have, as your assessment outcome to understand, because it's an inaccessible thing. You can't tell. You can tell whether they know or they can do. You can't tell if they understand. And yeah, it's not at the moment great at maths. Okay, it's all it's doing is putting words down or tokens. Yeah, and it doesn't actually get maths. It's happy to go and write code if you ask it to. Right. Okay, so I've got like 6 minutes to do 2 huge areas. Let's kick off with how might students use it. And some of you have got stories to tell already. This is quite fun. So getting it to role play is hilariously good. So let's hope that this works. I'd like to role play as Pythagoras. I'm 13 years old. I want you to use the Socratic method to teach me about your theorem. I know you're role playing, so you don't have to keep reminding me of that. So then you have the problem. Their homework question from the stuff we were talking about earlier is factorize x squared plus 6x plus 5. You say to it, can you help me factorize this? And it comes back with the answer. On this occasion, it's got it right. It's written code in order to solve this. So I'm reasonably, yeah. Okay. 4 is able to write code. 3.5 isn't. Okay. The problem is that feels like cheating. The point of asking them for homework to factorize x squared plus 5x, whatever it was, 6x plus 5, is not to find out the answer to that. You can do that yourselves. It's so they practice this. So it's better to get them, to show them that they should. I'm 13 years old. For my homework, I have to factorize this, teach me how to do this, and enter into and read what it says there or have it read out loud. There's this I can never pronounce this right, Khanmigo thing from Khan Academy in the US, which is available there for a subscription, which does that work for you rather than you have to ask it to teach you this. So, okay. Tell me the problem or exercise you'd like to solve. Half plus 4/5 plus 3/7. Delightful addition of fractions. To add these fractions, we need a common denominator. So it enters into a teacher-like conversation about this is how to do this and works through this. My daughter does this Simon Singh parallels thing. Anybody? Parallel circles. It's really good. Okay. So here you go. A student asks her maths teacher if he would reveal his age. Seeing an opportunity, the teacher replied with a riddle. My age in years is not a prime, but is odd. When the digits in my age are reversed and the new number added to my age, the result is a perfect square. Of course, if you prefer, you can take my age and reverse the digits, subtract that from my age, and still get a perfect square. Okay? Generally, at these conferences, people now get paper out and go and solve the problem. I'm going to move on. Okay. So this was the first one. She and I tried sending it to the machine intelligence, and it responds immediately. One number that satisfies these conditions is 63. 63 is odd and not a prime. When you reverse the digits and add them to 63, you get 72, which is a perfect square, 8 squared. You could also reverse the digits of 63 and subtract them from 63 to get 48, which is also a perfect square. You know, this whole thing about, I know this, I've worked this out, that's sort of, and your example about, look, ChatGPT says, fortunately she didn't sort of hand that in. I tried it today and it kind of gets it right now and it explains its method. It then does this weird thing. Look, you figured out at this point that it has to be, if you, what is it? So 11 times the sum has to be a perfect square. That's going to be 121. So we're looking at the numbers 6 and 5. 9 times the difference has to be a perfect square. So we're looking at either 9 or 81. It's going to be 9, isn't it? So we've essentially got a solution at this point. But at this point, it can't make that leap, and so goes off and writes some code to try all of the possibilities. But it does, fortunately, get the right answer. Okay, I'm worried about the time now. Okay, this is more from the Simon Singh thing. It gets this one right. Here's its answer. It gets this one right. Here is its answer. Again, it's written code in order to do this. And gives a good explanation of this, because I prompted again with, can you do this without writing code? Can you give me a reason? Because it will go to brute force approaches of try all the possibilities rather than thinking about it. Familiar from your teaching? Okay. And then, okay, this is the one that Ian talked about earlier. Prove that if A, B, and C are odd, then if the roots of the equation ax squared bx and c are real, they must be irrational, and the discriminant is not a perfect square. Sitting over there whilst they were talking on their video, I just type in the problem and it gives me a really nice 2-column, 2-page proof of this conjecture. I think that's theorem. I think that's a pretty impressive use of it. And okay, it's been a while since I was teaching maths, folks, but I think it's right. I couldn't spot any mistakes in there. You've got access to the slides later. Big data question or the large data set question at A level. Do you remember the one that AQA did with the cars? Huge long table. Okay. Can you give me a summary of the data here? And so, yeah. This is the first time I've seen this. It says, I can give you this answer or I can give you this answer. Which do you think is better? At this point, I'm going that third column of training it. So it will pay attention to the view I give here. Gosh, right. And so give me a histogram. Yeah. Okay. Construct a 95% confidence interval of the mean CO2 emissions of UK cars. Well, it's going to be between 136 and 138 grams per kilometre on the basis of that old data set, which is, I think, pretty cool. Show me that as a box whisker plot, and we get the box whisker plot. And then can you test whether propulsion type 1 produces significantly more emissions than type 2? Significantly? Well, Charlie says it's higher, but I don't know. Significantly higher? So yes, that is way significant. What is that? 2.43 times 10 to the minus 119. Now, I know that large data set very taught very badly because I just don't want to go anywhere near it. So, thank you. I have some really good materials. Talk to them later. But by and large, it's not. I've not done any by hand. I think, and this is interesting. Students, this. Certainly. Sorry? Yeah. And I'm teaching folks doing a master's in quantitative research. I always have. None of them are statisticians. They're going to end up doing qualitative. Good for them. And being able to ask intelligent questions and interpreting these results intelligently feels as though it's the sort of thing which a social science research should be able to do, even if they're not hand calculating with the data. I don't know. I feel conflicted. Oh, yeah. So type 1 significantly more carbon monoxide? No, CO2, carbon dioxide emission than type 2. One of these is petrol, one of these is diesel. Which way round is it? Yeah, type 2 is the diesel, which is, I don't know, why am I having to pay the ULEZ on my smelly diesel car? And then we get the scatter plots, color code this by the engine type, and we've got all of that. Then we get this sort of thing where it goes wrong. 6 pool balls are arranged in a triangle as shown. What is the arrangements of 1 to 6 so that each ball is the difference between the 2 balls below it? I took a photograph, it's a PDF, so I just did a screenshot of the PDF, sent it the screenshot with no request at all. Just, here, look at this picture. And then it says, oh, that seems to be a question. Let me answer that for you. Yeah? Because it's so wrong. Okay. And it says things which don't make sense. A 4 on top is possible if the middle row has a 5 or a 1 or vice versa. To get a 5 in the middle row, the bottom could be 6 and 1. No, it can't, because you've got 2 1s then. Yeah? It can't yet do maths well, despite the examples I've given already. I can teach it a method. It can help me. But all I do here is, okay, try all of the possibilities, ignore all of the ones where the numbers come up more than once, show me the correct answers. I've not done any mathematical thinking here. I could write code for this, but it's so much quicker to get it to write the code to solve this. And for what it's worth, Gemini and Claude also get it wrong, but in entirely different ways. They can't do this. Okay, look, we've run over, but let's just finish with some of this. Where would you draw the line? Do you feel it is cheating if your pupils get ChatGPT to explain something? Give them ideas for their homework, suggest how to improve that right there. Hands up if the first one is cheating. Second one? Third one? Just not sure. Fourth one? Yeah. Pretty much every audience I do this with draws the line in exactly the same place. Why? We will do the first 3 for them. We don't mind if their friends do it for them. We know their parents are likely to do the first 3 for them. The fourth one, they're not going to ask us. If they ask their friend, they know that's wrong. If their parents do it, they should know. The wrong method for long multiplication or whatever it is. So the first 3 feel entirely appropriate for us as teachers. The fourth one definitely is not. And I think that gives us a very good ethical basis for it's fine to ask for help, but it's not fine to just make the machine do all of this for you. And you know JCQ have rules about this. Personal statements, so don't if you're teaching sixth form, do not let them get ChatGPT to write their personal statement for UCAS, all right? Okay? Because we won't like that. And UCAS are quite clear about that, okay? It's fine to get it for ideas, fine to get it to check what they've written, but it's not fine to get just copy and paste its personal statement. Okay, let me see which matters here. Oh yeah, this is quite fun. We talked a little about bias in the training data. I don't think I did, but I hinted at it. Can't turn the lights off. The illustrations on the left are what it produces for a picture of a mathematician. The illustrations on the right are what it produces for the picture of a maths teacher. It's not as bad as it is in computing, but this is not an entirely representative group of pictures. You will find that that most of us seem to be wearing spectacles. There's a preponderance of facial hair there, and one gender seems to dominate in these pictures. I don't know. The chap on the top right seems pretty chilled, though, doesn't he? I think he's got it working right. Language seems to matter. Oh, and then, the really worrying stuff. Talk is the currency of learning. How we develop and shape our ideas, deepen our thinking, explore subject matter, and share our thoughts. It is so well read and so good, so articulate with language that unless we really keep checking ourselves, we're communicating with a person. because everybody else who's anything else that is that articulate is always a person for us. And realizing it's not a person is really hard. And I don't know, I just worry that since a year last November, the talk isn't with other people. The talk is sometimes with the machine. What? Well, yes, but yeah. Yeah. Not yet, but Khan Academy, Frontier AI, we're getting to it. Tutoring works, yeah. One-to-one tutoring, really expensive, but huge impact. And once
it's an expensive way to.
Okay.
More students in
They could teach each other. That's really nice. I love the Anthony Seldon stuff about, think back to your own experience. This is desirable difficulties all over again, isn't it? The stuff that you really had to think hard about is the stuff that still stays. Stuff that comes easily. It came easily. I wasn't thinking. What is it about memory is the residue of thought? Unless you're thinking, you're unlikely to remember. And just getting ChatGPT to write your lesson plan, you're not thinking about it. Getting it to do your maths homework, you're not thinking about it. You won't remember this. There's some lovely work from the US National Council for Teachers of Mathematics. They have a really clear position statement on this, which I'm not going to read to you. And their current president, very, very articulate about we need to rethink maths education because of what these tools mean, because of the way these things have changed now. Mathematics must be more than merely following a rote procedure to generate a correct answer. Please put your hand up if you disagree with this statement. But it's brought it to the fore again, yeah? Some of you may have been around in the 70s when, no, I don't think, when no, none of you, when the calculators came out. I was at school in the 70s, yeah? You can't rely on a calculator. You won't always have it. Yes. And then, so I think this is going to be the last slide, really, folks. This thing about Q-Star, do you remember that brief period when Sam Altman was sacked CEO, and then after the week came back? The story has it that it was the board CERN star version. According to Reuters sources, Q-Star. Hey, big deal. But it turns out language, that's really the whole strategic problem solving. Here's a long-term goal or a medium-term goal that I am aiming for. I've worked out. Okay, after these two words, write this. Is all that the star board scan. Yeah, but that idea of once you have language, meant, you know this from the kids you taught. It is interesting that seems to be an issue when it comes to the AIs, as to once we add in the ability to do even just high school math, it becomes very, very powerful indeed. Hey, listen, I'm so sorry I overran. Those who've heard me speaking before will know that this happens all of the time. I must get better at this. But thank you so much for hanging around and joining in. I'm going to stop the tape now, but I'm going to stay